Next problem asks us to find the area under the curve using rectangles. You can use your graphing calculator to figure out what this graph looks like, but really the key thing that you need to know is how to set what values you're looking for from the left and the right side. So let's just pretend, since this is a positive x squared curve, it looks something like that. Here's where I'm starting at 2, here's where I'm ending at 4, and I'm trying to approximate this area. Since I have 4 rectangles, in order to find the length of each rectangle, I'm going to take b minus a over n, where n is the number of rectangles, b is the right endpoint, a is the left endpoint. So here, 4 minus 2 over 4 gives me 2 over 4, or 0.5. That tells me the length of each rectangle will be 0.5 along the base. So if I'm doing left-sided rectangles, I'm going to need to find f of 2, the left side starting point. Then I'm going to have to move to 2.5, 3, and finally 3.5. If I'm doing right-sided rectangles, I'm going to have to start at 2.5, go to 3, 3.5, and finally 4. So multiple ways I can do this. I can put it into y equals, find values. I can just plug it in as I go. I'm just going to plug in, so 3 parentheses, 2 squared minus 2 times 2 plus 1. When I put that all in, I get a value of 9 at 2. If I now do the same thing at 2.5, that gives me 14.75. If I do the same thing at 3.0, that gives me 22. And finally, if I do it for 3.5, that gives me 30.75. Last one I'm going to do is just put in 4, because everything else is going to be a repeat when I go to do my right-sided rectangles. So when I put this in as 4, that gives me 41. I can then copy over that 3.5 was 30.75, 3 was 22, and 2.5 was 14.75. I've now gotten the heights of each of the rectangles by the left side approximation and the right side approximation. I could add them all together and find total height, but really that wouldn't give me the area of the rectangles, that would just give me their heights. I need to remember that the widths are 0.5 each. So really to find area, I should be doing times 0.5 for each of these. So 9 times 0.5 equals 4.5. 14.75 times 0.5 gives me 7.375. This gives me 11. And 30.75 times 0.5 gives me 15.375. If I add all these together, 4.5 plus 7.375 plus 11 plus 15.375, I get a total of 38.25, which is my left-sided or low-end approximation. When I do the right side, this is going to give me 7.375, this is going to give me 11, this is going to give me 15.375, and this is going to give me 20.5. I could add these all up, or I could just see, well, I'm getting rid of this 4.5 because I don't count that first rectangle, and I'm adding this 20.5. So that means what I'm really doing is adding 16 to my total. For that reason, I get 54.25. I would get that same 54.25 if I just added these 4 numbers. So what I'm going to put in as my answer, low end approximation or left side approximation 38.25, high end or right side approximation 54.25. Questions 8 and 9 tell me to do the limit definition in order to solve the problem, but really you should just use the fundamental theorem of calculus. So here when I integrate x, I add 1 to the power, it becomes x squared. I divide by the new power over 2, and this tells me I'll be evaluating from -6 to 4. First thing I do is put in 4. 4 squared over 2. From that I subtract when I put in -6. -6 squared over 2. 4 squared is 16. -6 squared is 36. This ends up being 8 minus 18, which gives me a final answer of -10. For problem 9, again, I'm going to use the tools I know are coming in the future rather than limit definition. So here when I integrate, x squared becomes x cubed over 3, and 1 becomes x. This is all being evaluated from 3 to 4. So I start by putting in the 4. That gives me 4 cubed over 3 plus 4. I subtract from that, putting in the 3. 3 cubed over 3 plus 3. 4 cubed is 64. So this gives me 64 over 3 plus 4. Minus 3 cubed is 27. 27 over 3 is really 9. Minus 3. That's -12 plus 4 gives me -8. So I have 64 thirds minus 8. That's really 64 thirds minus 24 thirds, which gets me to my final answer, 40 thirds. I also could always put that into my calculator and get 13.3 repeating, but I think Cengage would prefer it as a fraction.